using the squeeze theorem. So x tends to 0, so we only need to care about the points where x very close to 0. So we can think of x between pi divided by 2 and pi divided by 2. So we don't need to worry about x way too far from 0. So we look at this interval. So remember that this function is not divided by, it's not well defined 0. So now let's consider x from 0 to pi divided by 2. So in the unit circle, x is here between 0 and pi divided by 2. We see that psi of x is the length of the red segment. Cosine of x is the length of the green one. And as we know before, actually tangent of x is, we draw the tangent line here, extend this one, it cut at this point the length of this segment. This length is tangent of x. So we have 3 pieces here. The first one is this right triangle. Angle is 90 degrees here. Second one is the circle sector, this one. And the last one is this right triangle. So the orange one is the smallest area, then we have this circle sector, then we have the biggest right triangle here. Area of the right triangle, this length, hypotenuse is 1, cosine x and sine x, less than the area of the circle sector. Less than the area of the right triangle. 1 here, tangent x here. Then we compute all those area. Area of the first one is easy. It is right triangle. One length is cosine, the other one is sine. This area is 1/2 cosine x, sine x. This length, okay, now for this circle area, we know that, say, r, radius r, area of the circle of radius r, pi r squared. In our case, r equal to 1. So pi 1 square pi. So if we have 2 pi, the angle is 2 pi. Then the area is pi. If we have only 1 radians, the area will be only pi divided by 2 pi. Right? If we have 2 pi, it is pi. If we have only 1, then pi divided by this 1/2. So now you have not theta but x. if we have x here, then this angle will give us 1/2 x. So in our case, we have x here. This circle sector will give us area 1/2 x. This one here. Now we look at the last one, area of this right triangle. So again, it's just 1/2. One length is 1. This length is radius 1. The other one is tangent x. So we have 3 area. So we have 2 inequality. This one less than this one less than this one. From the first equality, we know that, let's just divide everything by 2. So we have this. From the first inequality, we have sides of x. Let's say cosine of x here, divided by x less than 1. Now we divided cosine of x, you would have sine of x divided by x less than 1 divided by cosine of x. So that comes from the first inequality. The second inequality is here, would give us the following. Tangent of x is sine of x divided by cosine of x. So this one will give us sine of x divided by x bigger than cosine of x. So forget this tangent. You have 1 less than this. Therefore, sine x divided by x bigger than cosine. So now combine the 2 inequalities. You have sine of x over x bigger than cosine of x less than 1 divided by cosine of x for the angle x between 0 pi divided by 2. So that is the first case when x is s. Now you can do the same trick, or you can argue by the even function. If x is from minus pi divided by 2, so this is correct picture. X is from minus pi divided by 2 to 0, you can do the same thing. Or you can say that now we have consider if x between minus pi divided by 2 and 0. Know that minus x between 0 and pi divided by 2. So we have look at this unit circle. X minus x. X we are here. Minus x is here. This is sine of x. This is sine of minus x. The sine of minus x is minus sine of x. Cosine of minus x equal to cosine of x. So just what you should remember. Sine of x divided by so now x minus x is between pi 0 and pi divided by 2. I can apply this here. I can use these inequalities for x equal to minus x. So everything here should be true for minus x. This is true for minus x. Minus x, minus x, minus x, minus x. Cosine of minus x equal to cosine of x. Sine of minus x is minus sine of x. Minus x 1 divided by cosine of x. So minus minus can cancel out. So this inequality is right here, and this one true for all x from 0 to pi by 2 and minus pi divided by 2 to 0. So it is true for both when x tends to 0 plus or 0 minus. 0 here, x tends to this left or right is still, the inequalities here is still true. Therefore, we have cosine of x less than sine x, x 1 divided by cosine of x for all x between minus pi divided by 2, pi divided by 2, x non-zero. It's better notation you can write for all x between this minus 0. Yeah. X tends to 0, cosine of 0, cosine of 0 1. This one tends to 1 divided by cosine of 0, 1 divided by 1, so 1. And therefore limit of this when x tends to 0, squeeze between between 1 and 1, so that this one will be limit 1. Limit of sine x divided by x is 1 when x tends to 0.